In the diagram, each letter from A to H is equal to a different integer from 1 to 8. Also, H is a perfect square, 1 more than D. 5 and 8 are in the same row. C is a multiple of both G and D. B is the largest prime, and B plus G is even. What is the value of F? Okay, well, let's play with this game that they're giving us. First, let's write out the numbers from 1 to 8. And let's see. H is a perfect square, so and it's 1 more than D. So it obviously has to be greater than 1. And the only perfect square in here that's greater than 1 is this guy. So 4 is H. Okay, so that's pretty much established. So we can put the 4 here. 5 and 8 are in the same row. Okay, that doesn't help me right now, but I can just sort of connect that there. C is a multiple of both G and D. C is a multiple of G and D. Okay. Again, that doesn't really help me right now. So let me just skip that. B is the largest prime number in the set. Okay, well, that's the only one I can get for sure. The largest prime number is 7, so that's B. B plus G is even. Okay. Again, right now that doesn't help me. So let's go back here. H is a perfect square and is 1 more than D. Okay, well, the D, therefore, that would be 3. Since H is 1 more, okay, that's pretty good. Let's fill this in now. So D was 3, and then B was 7. 5 and 8 are in the same row. Okay, I still don't know where 5 and 8 go, but they could go in the AE or the CG. CG. C is a multiple of G and D. Okay. C is a multiple of G and D. Okay, that we know D. Okay, so that's the one that I can probably do. So C is a multiple of G and D. We don't know G yet, but D is 3. So if C is a multiple of D, then C is most likely the 6. Yeah, okay, so that's good. So C is 6. Okay, then we can go back here. 5 and 8 are in the same row. So that's obviously up here. 5 and 8. I don't know which one is the A, and I'm just going to assign A to this guy and E to this guy. But they're in the same row. Okay, so now we're kind of getting somewhere. B plus G is even. B is 7. And G, we don't know. But if it's even, then that G has to be the 1. Okay, there we go. So then by process of elimination, the F is equal to 2. And therefore, that means the answer is A. ABCD has vertices A, B, C, and D. AB is parallel to CD. BC is parallel to AD. R is less than 0. What is the value from R plus S plus T? Let's see where we can go with this. Okay, I have absolutely no idea how to draw this, but let's just go. So 3, 2 is approximately here, minus 3, 2. Minus 3, minus 2, like that. That's A, right? And then R, 0, R, where they told me R is less than 0, so it's got to be somewhere here. 0, R. And that's B, right? So let's join that for now. And then 6, 10. So 6, 10 is somewhere here. 6, 10, I'm not sure where, but somewhere here. And then ST, well, ST I have no idea. So I'm just going to put that there. But one thing we know is that we've got these parallel lines here. Like this. So basically, AB is parallel to CD. So this is C and this is D up here. So that's why let's just draw those little lines that show they're parallel. And then BC, this one, is parallel to AD. So that's sort of what I'm trying to show there. Okay, that is pretty decent. Now let's try to figure out what is happening. So if we go from A down to B, right? We are, okay, let's see here, minus 3, minus 2. So we went this way 3, and we went down 2. correct? So since this is symmetric, if we went from D to C, it's the same thing. We'd have to go across 3 and down 2. Okay, so that means, what does that mean? So it means that D had the coordinates ST, right? So let me just put that here, ST. So that basically means, and C had 6, 10. So let me put that in first. So that means that if we take the x coordinate S plus 3, that is 6. Yeah. And therefore S is 3. And then similarly, if we get T and then subtract 2, we would get 10. Let me just see if that's correct. Yeah, I believe so. So, oh, this is actually not, that's not true. This here, let me think about this. So we went across 3 to 0, so that's fine. But here, we're going down 2, but we're ending up at R. So we're not actually, that is correct, that the 2 that I wrote there is fine. Like the coordinate, that minus 2, that's fine. But we actually have to figure out the distance from A to B, and what I'm referring to is the top to bottom, so vertical distance, and that is not 2 actually. That would be minus R minus 2, so this distance here. So let me just, that would be minus R minus 2. So similarly, this distance is not going to be 2. It's going to be minus R minus 2. Aha. So that means that if we take this T and then subtract from it minus R minus 2, we will end up at that 10. So, yeah. So that means T plus R plus 2 is 10, and therefore T plus R is 8. Okay, I think we have everything we need for R plus S plus T. So that's going to be, well, the R and the T, that's 8, and then the S is 3. So therefore that's 11. And that means the answer is B. The number 2013 is multiplied by a positive integer n. The last 4 digits of the result are 2025. What is the sum of the digits of the smallest possible value of n? So I think we're going to have to use that whole long division stuff. Oh boy. I think. So let's see here. So we got long multiplication. What did I say? Division? No, not division. So I don't know what n is, right? I have no idea. Let's see here. We got 2013 times n is something that ends in 2025. And 2013, in terms of its prime factorization, 3 times 11 times 61 times n. And it's some number ends in 2025. And I have no idea what n is. That's, I think, what we're trying to figure out. Yeah. Okay, well, let's, since I don't know, I'll make something up. Dot, 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 and we'll call it A, B, C, like in terms of the digits. So, 2013 multiplied by A, B, C, and we are trying to eventually get something that ends in 2025, right? So, we're trying to get this. Okay, so let's see. Well, the first thing I notice is that this has to have a 5. So we have to multiply 3 by something to get it to give a 5. And the only thing that could work is a digit. Like a C represents a digit from 0 to 9, right? So I think the only thing that works is a 5. Because if we have 5, then we're going to have 15, and then carry the 1, that's going to be 6, and then a 0, and then a 10. Okay, so at least we got this guy. So that means the C is a 5. Okay, so let's put that in there. at least for now. I don't know if this will work in the end, but let's just see for now. Okay, let's continue here. So the next thing we are trying to achieve is to get this 2, I guess. So let's see what happens. So we got 2013. We have the 5 there. And we've got this 10065. And then we got to insert this b, right? Okay. So let's see here. So obviously we have to do the 0. And then this is going to be 3b. And then it's going to be a whole bunch of other stuff. But I'm not really interested in the other stuff for now. Let me just add this up. 6. Well, I want it to be a 2025. So that means that this has to add up, 6 plus 3b has to add up to something that ends in a 2. Okay? So that shouldn't be that hard to figure. If b is 1, that would be a 9. If b is 2, that would be a 12. Okay, that will work. When b is 2, that'll be 6 plus 3 times 2, which is 12. And that does indeed end in a 2. Okay, so let's go with that for now. Let's call that a 2. Okay, so we go right back to the drawing board here. Same thing, 2013. We've got the 5 for the C. We've got the 2 for the B. And then we got this A. And our goal... Well, our goal is to get something that ends in 2025, but we already have this guy, which is 10065, and then 2, this guy will give me 2 times 3, which is 6, 2 times 1, which is 2, 2 times 0, and then 4. Is that right? I think so. Okay, so the 5 and the 0, okay, that worked. The 6 and the 6, that's a 12, carry the 1. And, oh, I forgot the A's. I got to do the A's before I do all that. Okay, well, I forgot the A's. Sorry about that. So let's do the A's. The A's, I got to go 0, 0, and then it's going to be a 3A. Yeah. Okay, so now let's try this now. So the 5 and the 0, that's 5. The 6 and the 6 is 12. Carry the 1. And then 1 plus 2 plus 3a. 1 plus 2 plus 3a. That has to equal something that ends in a 2, correct? Or hold on. No, let me do this. Let me be careful here. 1 plus 2 plus the 3a is this guy, 0. Aha. Okay, so it's got to end in a 0. Okay, got to be careful there. So that's really 3 plus 3a. Is equal to something that ends in a 0. Okay, so what would a equal? A is a digit, right? So if a, for example, equaled 9, that would be 27 plus 3, that'd be 30. So that will work. When a is 9, it'll be 3 plus 3 times 9, which is 30. And there we go. So therefore a is 9. And that means that was our n. So n is 925. And they want this, the sum of the digits. Oh, okay, so 9 plus 2 plus 5, and that is a 16. So the answer is E. In the diagram, circles are connected if they are joined by a line segment. Each circle is filled with one integer, so that the positive difference between each pair of integers is connected in connected circles is d, and the sum of the 5 integers in the circles is 54. For how many different values of d between 1 and 20 inclusive can the circles be filled in this way? So I think obviously this shape here is at the heart of the question, and there's a lot of different ways of creating this, because there's like for example, I'll just give one way. And they really don't give us much information either. All they tell you is that the positive difference between each pair of connected circles is d. So for example, let's say this was a, right? And therefore this one would be a plus d, and that satisfies that condition. that the positive difference between the numbers in two connected circles is d. And then therefore this one, for example, we can make that a plus d, and then this could be a plus 2d, and this also a plus 2d. And I think that satisfies the condition for all the numbers that are connected, that if you took the difference, the positive difference, it would be d. But the problem is that there's several different ways of arranging. This is just one arrangement. So first what I'll do is I'll put all the arrangements, and then we'll talk about each one. So I will move this up, and let's talk about each of these. So as you can see, there's looks to me like 7 of these guys, 7 ways of arranging the numbers so that the validity holds. So we can then make a table and then talk about these one by one. So let's make a little table here, and we've got case 1a. So 1a is this guy, and then we have 1b, this guy, 1c, this one, 2a, 2b, 2c, and then finally this guy, 3a. Okay? Now what we'll do for each of these is we will add up the sum, because remember the question told us that the sum is 54. So for this one, 1a, if we take this guy right here, if we take the numbers and add them up, it'll be 1, 2, 3, 4, 5a. And the d's are 1, 2, 3, 4, 5, 6, 6d. And that is equal to 54. And we will have to explore each of these. And so very similarly for the other ones, it'll be, let's see, where's 1b? So it's 5a plus 2d, that's 54. 1c is 5a plus 4d, that's 54. For 2a, it's 5a minus 2d, is 54. For 2b, it's 5a minus 6d, is 54. For 2c, it's 5a minus 4d, is 54. And then for 3a, it's 5a, and that's 54. Okay. All right, we'll move this up because I'm going to need some space. Okay, so for each of these, we've got to do some math. And so, oh boy. So this is basically arithmetic at this point. Oh boy, oh boy. So I guess I just have to kind of keep in mind that D is anything from 1 to 20, and they're basically asking how many of those values are valid, right? If I remember correctly, for how many different values of D between 1 and 20 inclusive can the circles be filled? Okay, so the maximum obviously is 20 since there's 20 numbers, but what are the answer choices here? Yeah. So, oh yeah, see, as you can see, the maximum is 20 and then 16. Okay, that makes sense. So we have to figure out how many of those 20 are actually valid. So it just boils down to these equations. Can we get integer solutions, right? Because the numbers are all integers. Let me just double check here. Each one integer, yeah. And it doesn't tell you if it's positive or negative, though. Yeah. The sum of the 5 integers is 54, and the positive difference, okay. So the integers might be negative, meaning the values of A. They might be negative, but we'll see. Okay, so I just wanted to make sure I understand the question properly. All right, here we go. So first this guy, we have to get integer solutions. And, all right. So it's a very time consuming, you got to figure out. So when D equals 4, A would equal 6. When D equals 9, A equals 0. When D equals 14, A equals minus 6. And when D is equal to, I believe 19. you're going to have A is equal to minus 12. Okay, so far we've got 1, 2, 3, 4 values of D. And those are the only values that give integer solutions for that guy. In a very similar way, you have to find integer solutions for this one. And those are when D equals 2, 7, 12, and 17. And you can calculate the corresponding values of A. Very similarly for this guy, the integer solutions are occurring when D equals 1, 6, 11, and 16. For this one, the integer solutions are when D equals 3, 8, 13, and 18. This one gives no integer solutions. No integer solutions. This one also gives no integer solutions. And the last one also gives no integer solutions. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16. And you just got to make sure you didn't double count. And therefore 16 is the answer, and that would be E. The list 11, 12, 14, 23, 31, 44, 45, 46, 56, 64, 67, and 74 can be arranged so that the units digit of each number matches the tens digit of the number that follows it. For example, 12, 23, 31, and so on is one such arrangement. How many such arrangements of the given list are possible? So let's try to understand this. So if you can see this arrangement here, this one, right? Notice you got the 12, and then the 12 is the units digit of that first number, right? And then the next number, the tens digit, is the same, 2. And then the units digit of 23 is 3, and the tens digit of the next number is 3. So that's what they're doing. They're matching the units digit of one number with the tens digit of the next number. Those numbers have to be the same. So that's what they mean. So that's fairly straightforward to understand. Now they're saying that this is one such arrangement. They're saying how many such arrangements total for these numbers right here. Okay, so let's see if there's some system here, because otherwise it would be way too difficult to do trial and error, way too time consuming. Okay, so the first thing I want to do is just talk about the digits. So if you look at it, the digits of those numbers, I think everything is from 1 to 7 only. There's no 0, there's no 8, and there's no 9, I believe. Now let's see, how many times does it appear as a units digit, and how many times does it appear as a tens digit in this list right here? And I think it's 2, 3, 1, 1, 1, 1. The 4 appears 4 times as a units digit, 3 times as a tens digit, 1, 1, 2, 2, 1, 1, like that. Okay, so everything matches except the 1 and the 4. So that means there's one extra 1 as a tens digit, correct? And one extra 4 as a units digit. So what that makes me think is that these arrangements start with a 1. And then you have all these numbers, and then at the very end it ends with a 4. That's the only way this is going to work. And then everything else matches. That's why the numbers match in this little table that I made. So that's my first observation. Okay. So then what I will do is I will try to find a system that helps in some way. Let's see here. What is that system? So I think there's some benefit to breaking these numbers up. These numbers, how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Is that right? 12 numbers? Yeah. So if we break it up into groups, I think that'll be easier. So I'll put the smaller numbers first in one group. And then I'll put the larger numbers in another group. And that might be a little easier. 56, 64, 67, 74. Okay. And then yeah. And then it starts with a 1, ends in a 4, but there's got to be a connector because there's a 14 that I forgot, and I believe that 14 is what you call a connector, meaning it connects the two groups. Okay, so, and there's only one way of putting that 14 in the middle. But with these guys, I think it's kind of limited. It's got to start with a 1, so the first number has to be an 11 or a 12. And then let's just see, if that's an 11, the next one would have to be but 12. And then the next one would have to be the 23, and then the next one would have to be 31. Okay, so that's for sure. If it starts with a 12, the next one would have to be 23, and then a 31, and then an 11. Yeah, so as you can see, there's two ways of arranging these guys. And there's obviously only one way of arranging that. Now we turn our attention to the big guy, the big group. Okay, that big group, we know for sure that it starts with a 4. Starts with a 4 because this ended with a 4. So we got a 4 there. And if it's, let's see here. Let me save this guy for now. Let's start with the 45. If it's a 45, then the next number has to be 56. That's the only way. So these two are always going to be together. And if we start, well, if we start with a 46, oh, then you got two choices. You got a 64 and a 67. Aha. So it's not as easy as I originally thought. Okay, so 45 and 56 go together. And then after 56, you can have 64 or 67. Yeah. 45, 56. Okay. So you could have 64 like that, but you could also have 45, 56, and 67. You see, there's two choices there. That's why. And then I'm trying to think, after 64, do I have other choices? And the answer is yeah, I do, because it could be like a 44 or a 46. Yeah. But what about a 67? I have no choice. These two have to be together. Okay, so that's actually pretty good. So let's work with that. I'm just trying to group things together, so the ones that I know absolutely have to go together. So let's work with this. This is going to be 45, 56, 64. And then, well, okay, so I used the 45, I used the 56, and I used the 64. So I got to put 46, and then 67, and then 74. Right. Okay, so that takes care of this guy. But we left out the 44, but the 44 I'm going to put in at the end. Because because there's two 4s, there's a lot of places that could go. Any other way of arranging this guy here? I think so. You could do a 45, 56, 64, and then you could put these guys up here in the front, 46, 67, 74, like that. So those are just a flip, I think. Yeah, 45, 56, 64, and then 46, 67, 70. Okay, that's good. And then for this guy, this group, we'll bring that group down here. And that's 45, 56, 67, 74. And then, so that was 45, 56, 67, 74. And so 46 and 64 are left. So 46 and 64. And then I think the same kind of thing that we just flipped them. So we do that, and then we put the 46 and 64 in the beginning. Okay. Now, of course, for all of these, I left out the 44. So let's see. For this one, the 44 could go in the front, or it could go at the very end, or it could go in the middle. See? So I have three possibilities there. And then same thing for this guy. 44 could go in the front, it could go at the very end, or it could go in the middle. And similarly, the 44, 1, 2, 3, 4, yeah, 44 could go in the beginning, at the end, or in the middle. And similarly with the last one, the 44 could go at the beginning, at the end, or in the middle. So we got 1, 2, 3 ways of arranging those guys, another 3 ways of arranging that, another 3 ways of arranging this, another 3 ways of arranging this. So these guys have a total of 12 different arrangements. So the grand total would be this times this times this. So the grand total is 2 times 1 times 12. So 2 times 1 times 12 is the grand total, and that's 24 arrangements. And therefore, the answer would be B.